take an amount of an amount, use multiplication to find the result. Same is true with whole numbers as well. If I have 5 groups of 6, if I have half of 10, that's multiplication. If I have 3/8 of 2/3, multiplication. I've heard some people just say, oh, if I see of, it means multiplication. Not exactly, because if they say 2 out of 3 people recommend pepsidase, 2 out of 3, that would be changing to 2/3. So out of is different. That changes something into a fraction. But if I want to take an amount of an amount, then we're dealing with multiplication. So to find the product, which of course is the result of multiplication, of fractions, put the product of the numerators over the product of the denominators. Or as I like to say, you multiply across the top, multiply across the bottom. And then here it says simplify if needed. The next part of the notes will be the whole simplify before we multiply, but the most basic, direct thing to do is just to multiply across top, multiply across the bottom, and then simplify. So we're going to have 2 examples here. 4/5 times 7/9 will be our first example. So who can tell me what I get as my product numerator when I multiply across the top? Yes, ma'am?
28.
28. And what am I going to get as my product's denominator?
45.
45. And can that be simplified?
No.
No. That's also part of why I like to simplify before I multiply, because neither one of those is prime, so I sit there and rack my brain going, can I simplify anything? I actually personally look back at my original numbers and think, could I have simplified anything? Well, then next one, again, we're not going to do simplify before we multiply for these examples, but gosh, we sure want to. So if I was just going to do 3 times 6 over 4 times 7, what would I get as my product?
18.
18 over
28.
28. Can that be simplified? Or be simplified to?
You can simplify it to 9 over 14.
9 over 14. Now, if it's possible, it's best to simplify before you multiply. We're going to see several examples where we'll use that strategy. So what it means is you can divide a number from one of the numerators if you divide that same number from one of the denominators. Since in this previous example we divided by 2 on the top, we divided by 2 at the bottom at the end of our work, we could instead divide by 2 on the top, divide by 2 on the bottom prior to multiplying, because it's going to make an equivalent multiplication expression. Fractions won't be equivalent, but the entire multiplication expression will end up being equivalent. So for this first example, we're going to redo that one. So 3/4 times 6/7. What can I simplify before I multiply?
Or you can make it divided by 2 and get 2, and divide 6 by 2 and get 3.
Good. So the 4 and the 6 are both even numbers, so I can divide 2 out of each of them. The 4 becomes 2, the 6 becomes 3. Is there anything else I can simplify before I multiply? No, because these 3's are on the same side.
Oh, wait.
My simplifying step at the end, I would not be dividing out 3 repeatedly on the top. That doesn't keep things equivalent. Now we multiply across the top, multiply across the bottom, and what do we get for this example?
9 over 14.
9 over 14, just like we got when we simplified after the fact. You might have 3. Oh yes, that's right, 3 numbers getting multiplied.
Oh, watch out.
So you might have more opportunities to simplify before you multiply. I wrote your last one wrong. My bad. So it's supposed to be 2/3 times 9/11 times 3 over 10. If you did it without simplifying before you multiply, you would do 2 times 9 times 3, which isn't pretty but isn't impossible. 3 times 11 times 10, which isn't pretty but isn't impossible. But then at the end you have to try to simplify it, and that's the part that's a pain. So let's try to simplify before we multiply. Just tell me one thing you see.
2 and 10.
The 2 and the 10. So we're going to divide each of them by what? 2. So this 2 becomes a 1, this 10 becomes a 5. Is there anything else we could simplify before we multiply?
The 3 and the 9
The 3 and the 9 could each be divided by?
by 3.
By 3. Now other people might have seen the 3 and the 3 quote unquote cancel out and they both would become 1. Either way we're going to get the same result. But this now becomes 1 and this now becomes 3. So I can no longer manipulate the 3 on the bottom because I already used it. If I had something remaining, we're going to see something later, that I can still divide out, that would be fine, but right now I have on the top 1 times 3 times 3 over 1 times 11 times 5. So at this point, there's nothing else I can simplify. So what do we get as our product?
9
Mm-hmm.
over, it's 55.
Yep, 9/55. Good. Now we're going to get into the mixed number part. So I'm going to clear the ink. Everyone's got that so far then? See, if one or more of the factors is a mixed number. It says number, but then I ran out of room and started going slanted. You can change any mixed number to its equivalent improper fraction. Then simplify and multiply. You might still, at the end, even though you simplified beforehand, you might still not have a final answer because you might need to change an improper fraction to a whole number or a mixed number. We didn't need to talk about that before, because if I'm taking a fraction of a fraction, my answer is going to be a smaller fraction. But if I'm taking a fraction of a mixed number, or a mixed number, amount of mixed numbers, then I might have something that's bigger than 1. So examples. The first one we have here, 4/5 times 2 and 1/2. So this is what I call a roadblock. If I try to multiply across the top, that 2's in my way. If I try to multiply across the bottom, that 2's in my way. So it's a roadblock. So I'm going to rewrite this as 4/5 times, what is 2 1/2 equivalent to as an improper fraction? Yes, sir.
5 halves.
5 halves. And now I look at it and say, is there anything I can simplify before I multiply?
Divide the 5s by 5.
Yep, those 5s cancel out. Divide by 5, and I get a 1 there and a 1 there. The identity proper multiplication says that's not even going to change my answer. Love it when I can divide things down to a 1. Anything else I can simplify before I multiply? Yes, sir.
4 and 2.
4 and 2 can each be divided by what?
2.
2. So this will become a 2, this will become a 1. Now when I multiply, and every single thing in the denominators are 1s, then I know my answer is going to be a whole number. So I do let you not write the step where you come up with the final product. If you see that everything on the bottom was 1s, then you just have 2 times 1 is 2. So in this case, I do let you skip the step of writing 2 over 1. Because anytime you have something divided by 1, it equals that something. So 2 times 1 is going to be our final answer there. The next one we have for an example is 3 1/2 times 2 2/3. So I've got 2 roadblocks to get rid of. Who can tell me what 3 1/2 would be as an improper fraction? Yes, ma'am. 7 halves. Shh. What would 2 2/3 be as an improper fraction? Yes, sir.
8 over 3.
8 over 3. So I made an equivalent multiplication expression. I want to see if I can make an equivalent multiplication expression by simplifying anything now. So I did need to rewrite in order to get rid of those roadblocks, but now I can go ahead and I can just change things by dividing out common factors. So what do you see that I could divide out?
The 8 and the 2.
Can it be divided by?
2.
2. I can divide a 2 out of the 2 to get 1 and a 2 out of the 8 to get 4. And I believe that's all. So when I multiply, what do I get? 28 thirds. And 28 thirds is not proper. So what would be the mixed number we would say as our final answer?
9 1/3.
9 1/3. All right, the last thing we want to put in our notes is dealing with the whole number. Keep it simple, just put it over 1. That's the gist of that. But then we'll have some neat examples going on. So if one or more of the factors is a whole number, and we're dealing with fractions for one of the other factors, you can put the whole number over 1 to have a numerator and denominator to simplify and multiply. And again, you might still need to make your answer proper. So if I have 3/8 times 4, I told you when we encountered that on the homework the other day that you can just put it over 1. And that takes care of the roadblock. I now have a numerator and a denominator. Now that I have a numerator and a denominator, is there anything I can simplify before I multiply? Yes, ma'am?
The 8 and the 4 can both be divided by 4.
Mm-hmm. The 8 and the 4 can each be divided by 4. The 8 becomes 2 and the 4 becomes 1. So I get 3 times 1 over 2 times 1.
3 over 2 or 1.
Which is... trying to steal someone else's answer. 3 over 2, which is not proper, so we make it
1 and
1 and 1/2. And the last example that we're going to put in our notes before you try it out all on your ownsies. 5 times 3 and 1/10 times 4/7.
Oh.
So 5 times 3 and 1/10 times 4/7. We're going to rewrite this to get rid of roadblocks. So the 5 is going to be rewritten how? 5 is equivalent to what that we're going to do?
5 over 1.
5 over 1. The 3 and 1/10 is going to be rewritten how? 31/10. And the 4/7 stays 4/7. Is there anything we can simplify before we multiply? Yes, sir?
The 5 and the 10.
The 5 and the 10. Someone else might have seen something else first, and that's okay. People will do things in different orders. Now I have 1 times 31 times 4 over 1 times 2 times 7. Is there anything else I can simplify before I multiply?
The 2 and the 4.
The 2 and the 4. Even though I already, worked on that 10 a little bit, I can't work on the 10 anymore, but I can work on what it became, which was a 2. So I can divide a 2 out of the 2, make that a 1, and a 2 out of the 4, and make that a 2. So now I have 1 times 31 times 2 over 1 times 1 times 7. That's it. Can't simplify anymore. So what do I get as my product when I multiply across the top and multiply across the bottom? What'd you get?
Oh, 62 over 7.
62 over 7, and then we go, oh no, one more step because that's not proper. What do we get when we make that proper?
8 and 6/7.
8 and 6/7.